Okay, so in this particular question, we've been presented a situation where we've got some aluminum and we've been told that it reacts with HCl, right? And once it does that, it produces AlCl₃ as well as H2. And well, we need to figure out, as the question says, we need to figure out what mass of AlCl₃ was produced from the reaction. And we've been told that 37.25 grams of Al is what reacted with the HCl, and that the HCl is in excess. Now, because the question states that the HCl is in excess, we know that the HCl is not the limiting reagent in this reaction. It's not the thing that will limit the quantity of AlCl₃ that's produced. The thing that will limit the quantity is going to be the Al, right? And based on that, we can basically effectively deduce that, well, if it's limited by Al, then using stoichiometry, we can effectively work out the mass of AlCl₃ produced, starting from the mass of Al which reacted, right? So let's go through that process. So the first thing I'm going to do is, in order to make a comparison, I need amount of substance, right? Which I've got a mass, but I don't have a amount of substance. So I'm going to get an amount of substance in the form of moles. And as we know from the equation, mass m is equal to the moles n multiplied by the molar mass mr, right? And in this case, we've got the mass. We need to work out the moles. So we can rearrange this by dividing both sides by the mr, right? We know that that will cancel on this side, so therefore we can say that the moles is equal to the mass divided by the molar mass. So we need the molar mass of Al to be able to work this out. Okay, so let's refer to the periodic table, right? So you can see aluminum here, right? Or aluminium, whatever you want to call it. So you can see the aluminium here, and we are, as you can see, the relative atomic mass is 27, and that's, in this case, actually is the same as, you know, what the molar mass is going to be, right? So the molar mass here, so mr of Al is equal to 27.0, okay? And that's in grams per mole. So with that 27, what do we need to do? Well, simply we use this equation, so we just plug the value in. So that's going to be 37.25 divided by 27.0, right? So I invite you to have a go with this on your calculator to work out what that would be in terms of the number of moles. And so if you had a go, what you should find is that for the moles, so this is actually, I'll just put here that the moles, this is the moles of Al, right? It's going to be 1.3796296 moles, okay? Now, okay, we've worked that out, but we now need to effectively figure out how do we relate this to the moles of AlCl₃ produced? Well, look at the equation. What does the equation tell us? The equation tells us that 2 AlCl₃ is on this side, and 2 Al is on this side, and 2 AlCl₃ is on this side, right? So long story short, both of them are the same. We've got 2, 2. So the actual ratio between them is, as far as the rate, let me just use the n here. So for the moles of Al compared to the moles of AlCl₃, the ratio is a 2 to 2 ratio, right? And if we just simply divide that by 2, we can, well, it's more or less means the same as to say it's a 1-to-1 ratio. So the moles are the same, right? And because the moles are the same, therefore, therefore the moles of AlCl₃ is actually the same, right? So it's going to be 1.3796296, right? And because of that, the main thing we actually need to do now is simply effectively convert this number of moles back into a mass. And how do we do that? Well, we're going to need some more information. We're going to need to be able to calculate effectively the molar mass of AlCl₃. Okay. So I would invite you to refer to your periodic table, have a go, see if you can work out the molar mass of AlCl₃. But if you do that, what you should find is you're going to get, here you've got, so 27. So let me just write this, AlCl₃ is equal to, so for the Al we've got 27, right? So 27 plus, and then get a bracket. So as you can see from the Cl, it's 35.5, 35.5, and then we have to multiply this by the occurrence, right? So here Cl₃, so it goes 3 times, so I have to multiply that by 3, and so that's going to give us the MR, right? And if we do work that out, you should find that you get 133.5, okay, grams per mole, right? Okay, so I've worked that out. I now need to use that value to work out the mass, right? So what we're going to do is we're simply going to use the equation again. So that is to say that the mass is equal to the moles multiplied by the molar mass, right? So if we use that, simply we say that the mass is equal to the moles 1.3796296. I'm just going to include the units here, right? Moles multiplied by 133.5 grams per mole, right? Okay, so feel free to have a go, see what you get when you work that out, but that is going to give us our mass, and what you should find from that is 180.5556 grams, right? So that's effectively the mass that you get. But then the question here is, well, is this our answer? Is this what we can state as the answer to this question? Well, if we refer back to the question, it specifies, please give your answer to a maximum of 2 decimal places. Now, clearly, our answer is, it's not to 2 decimal places. This is to basically to 7 decimal places at the moment, right? So we need to round this up to what it needs to be, or should I say round it? I'm going to say not round it up, but round it to, so 100. Okay, I've just put a decimal place there by accident, but that's going to be 184.18, right? So 184.18. That's going to be in grams. So to 2 decimal places, the answer is 184.18 grams. Okay, and so that's going to be the mass of right. Okay.